So we got 4 systems here. Checking out letter A. What's popping that we maybe should try to do again?
Add, because
I'm looking
if you
for
add
it.
an
Ivy, thanks for raising your hand, Ivy.
I would add because then we could cancel out the negative.
Yeah, so we just established if we add left side and add right side, the resulting equation is true. And then in this situation, if we do that, the result is 7y equals 21, which is nice because then I know that y is 3. And if y is 3, I can slap that right up in there. 2x plus 3 times 3 equals 7, which means 2x plus 9 equals 7, which means 2x equals negative 2, and x would have to equal negative 1. And remember, our answer is going to be the ordered pair where these two lines cross. In this case, negative 1, 3. All right? I want you to please solve B and C on your own. All right, checking out B. What we notice? Heinz, what do you notice for B?
There's negative 3 and 3.
Oh, so if we add these together, the y's are going to cancel?
Yeah.
Okay. So 5x would equal 10, which means x is 2. And if x is 2, I slap that right in there for either x. It doesn't matter which one. So I'm going to subtract 4 from both sides. You good with me taking that little quick step? Just a little deke. Which gives me 0.21 where these two things cross. Now we're looking at problems. See, Zeph, what's a little different?
What's different
Yeah.
is to cancel out one of the variables, you have to subtract instead of add.
Yeah, we got to subtract. Nothing's canceling.
Yeah.
So what I'm going to choose to do is multiply everything up here by negative 1. And then I like to put a nice simple line through it so I can still see it, but so I don't use it on accident. Because I've done that. I'm going to add these together to get y equals 4. Oh, that was kind of nice. And once I know that y is 4, I can plug it into either one. I'm going to choose to just go back to my original. Just 2x plus 3 times 4 equals 5. Subtract 12. Negative 7. So I got x is negative 3 and 1/2. There we go. There's my ordered pair. What happened here is I noticed these two x's I could get to cancel kind of nice. So I chose to multiply everything here by negative 1. It is subtracting, but the challenge with subtracting is sometimes people won't carry that negative through. If you multiply everything by negative 1, the negative automatically gets carried through. All right? So then, when I added these two equations together, note this equation is the same equation as this equation. I multiplied everything by negative 1. We know if we do the same thing to the left and right side, it's equivalent, right?
Yep.
I added, these cancel. I added and got a y. I added and got a 4. Once I knew y was 4, I can go put this in any equation. I chose this equation. So 2x plus 3 times 4 is 5. If 2x is negative 7, then x has to be negative 3 and 1/2. That ordered pair is the place where the two lines cross. Ivy.
So I just had a question. So if you find a system that doesn't have anything that you can cancel,
Oh, like D?
can you multiply everything by a number to change the number so you can?
Yeah, so Ivy said, can we multiply everything by a number to change the number? Well, I've got a question for you. If we multiply everything on one side of the equation and the other side of the equation, do we have a true equivalent equation?
Yes, we do.
Yes, we do. So that is definitely a tool in the tool belt. So looking at D, what is something that looks like we could get it to cancel maybe? Right? Yeah, x. I've got a 2x and a 6x, right? And I could get that 2x to be a negative 6x relatively easy, right? What do I have to multiply by? Negative 3. And if I do that to both sides, do I have a true equivalent equation? Yes. So that means that top line is equal to negative 6x minus 9y equals negative 48. It's the same thing, only different. I'll put a line through that just so I know not to use it. So really what I did is I used some of those two big ideas to do the same thing to both sides. And now I know that if I had left sides of my equations and right sides of my equations, that is also true. So if I do that, I get negative 14y equals negative 28. which means that y is 2. Once I know that y is 2, I can put that into any of these lines, because where they cross, x is x and y is y, the same spot, right? So I'm going to go, I like to put it right there in this case. 2x plus 3y equals 16. Take away that 6 from both sides. 2x is 10, which means x has to be 5. The place these two lines cross is 5, 2. Again, it goes back to the big ideas. The big ideas are, if you do it to one side and the other, we have an equivalent equation. If we add up left sides of equations that are true and right sides of those equations that are true, the resulting equation is also true. Like, for example, if we went back to this one, 8x minus 2y would be 36. It just doesn't help us figure out what x and y are, but it'd still be a true equation if I just add it as is. I manipulated it to make something cancel. Also, like for D, another thing I could have done, but it would have been way more work, I could have multiplied this whole thing up here by 5 and this whole thing down here by 3. And that would have canceled my y values. But it would have been way more work, right?